Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So today we have a hard today, which I think we had one like 2 weeks ago, but yeah, it looks like it has something to do with 2D grids. So let's see what it wants. So the question is called maximum number of points from grid queries. So you're given a grid, and you're also given an array of queries, and you have k elements in it. So let's see the size. So right, so we have 10,000 elements at most in our grid, and k is going to be 10,000. So I think we are going to be looking at some ON or n log n kind of algorithm. So yeah, so let's actually read the question now. So we want to find an array answer of size k, such that for each integer, queries I. So each of the query is it's just one number. So you start in the top left cell, and we want to repeat the following process. So queries I is strictly greater than the value of the current cell, then you get 1 point. If it is your first time visiting this cell, and you can move to any adjacent cell, right? So otherwise you don't get any points. So that means excuse me, I have been a bit sick for the past few days, so I'm sorry if I'm not that energetic, but yeah. So otherwise, you don't get any points. So if you have visited a cell already, I think you don't get any points. Yeah, or if whatever cell you're currently in. Oh wait, but you end this process. So if at any point it doesn't satisfy like this, do you just want to end all the query? Well, I guess we have to look at the examples to find out. Yeah, and also you get 1 point. So it doesn't really matter what like the actual number is. So after the process, answer I is the maximum number of points you can get. Note that for each query, you're allowed to visit the same cell multiple times. Wait, so answer I... I'm a bit confused on the question, but let's look at some examples, see what it tells us. So we have 5, 6, and 2. Let's say we are starting on the top left cell, right? Yeah, so it will be 0, 0, like on the indexing. So we want to start at 1. Wait, what? How do you get 5 points here? I'm actually so confused right now. Right. So the diagrams above show which cells we visit to get points for each query. Is this question hard because of how confusing the actual question is? We cannot get any points. Value of the top left cell is already greater than or equal to 3. Huh? What? Wait. Oh wait, does 5 mean? Oh, I understand now. I understand the question now. So let's say this is 5, right? You can actually repeat as many times as you want here. So yeah, so it is not like, so my misunderstanding was that like for this query you're only allowed to move once, but actually you're allowed to move a lot of times. So let's say like 1, 2, 3. Yeah, so you start at 1. The query is currently 5. Yeah, so basically you want to find the biggest connected component that has top left, while where every um every element in that component is is smaller than the query number. So that's why if we have 2 here, we're just getting blocked by the 2s. But when we have 6 here, we can visit like basically everything. And also we can't reach the 1 here because we have like a barrier like 557 for 5 that blocks it off. So yeah. So yeah, actually now that I understand the question, I don't think it is too hard. So you definitely want to sort the queries first, and then you just want to like do a DFS out gradually until until you can't go any more out, and then you just want to like loosen the bounds like on queries. So what I'm thinking is we probably want a queue. Oh, not a queue. Maybe like we want a min heap maybe that stores the value and also stores the position. So let's say like when we visit 1, we will like get the 2s. So we always want to go to the smallest possible first. So like let's say when we have visited like 1 2 3 here and the 2 3s here, well, the smallest thing we can go next to is 5, right? So if we have sorted the list, we can just count like how many elements we have visited so far, and so let's say for 5 when the smallest element in min heap is 5, we know that everything else next to our like current connected component has a value of 5 or larger, so we can't do any further. So yeah, this question is definitely not hard. It's just kind of confusing maybe, unless I'm missing something crucial. But yeah, so that means we only have to do like one DFS with a priority queue. So it will be nlog n, and it will suit here perfectly. So yeah, let's write the code now. So what we want, yes. So I guess we also want a map. So we want an answer map. So that's going to store for the queried number, what is the answer for it? And at the end we can just map queries like using this map. And then we can just get the answers for all of these, right? So yeah. So we have an answer map. What else do we need? I think we also want to sort the queries. Maybe we'll put this above. We definitely whenever we have like a great traversal, we always need a function to check if the cell is valid. So we want row column, obviously. So row and column. So that will be a length of grid, and then the length of grid 0. So it's self valid. We just want the coordinate of it. So we just want to return 0. Well, in Python we can actually just do this, which is extremely readable. J column. So that's very self-explanatory. We have a helper function here, and then so query sort, and then we have an answer map. So now we just want to do for queuing queries. Oh, actually, do we want to do that? I think we want to counter, right? Yeah, actually, how do we want to write this? I guess like we can just use a heap first. So from heap queue, import heap push and heap pop. So we need a heap, and then so we also should define what we are putting it inside. So we are putting let's see. So I think like because we want to sort it based on the value, like the actual value first, right? So what we should do is we should well, like we should make it a tuple that has the actual value and then the coordinate. So coord x, coord y. So yeah, we can define that, and then, well, for the first thing, we just wanna, yeah, what do we want to do? Yeah, we just want to get the value of the first. Well, we're starting at the top left corner, right? So, so of course we want to do, like we want the value there, and then our coordinate is just going to be 0, 0. Yeah, actually, we should do this, because we still need the actual order of the queries when we return the answer. So yeah, we just store the sorted one in another variable. So now, I guess we also need a scene set for all the scene coordinates, and we can also use this to count like how big our current connected component is, and we also shouldn't add the original, like the top left corner element into scene. Well, because we could have like an example 2 kind of case, right? Like where the query, like where the actual number is it's just like too large already. We also want an index, so that will be like the index of the query. Guess we can just do number of queries. We just do length of queries here. Oops, I didn't swap anything, right? Okay, good. So we want to start at 0. So while this is smaller than the number of queries, we want to like add as much element into our scene set as possible until until we couldn't add anymore, and then we want to like get the answer for that, and then we just want to repeat that, right? So while heap, and the first element in the heap is located at the 0th index. It's always at the front. So we want the actual value, and we want to compare that value with our sorted queries. Sorted queries, that's why I named it. Yeah, we want to. So the index is like which query we are looking at the moment, like for the sorted query. So we want it to be smaller, right? If I'm not wrong. Yeah, we want the actual value to be smaller. So we just do that. And well, if this doesn't, well, if this is true, we want to well, we want to get the value and then the xy's. So we're just getting like the value and the coordinate. I think you can do this. I think. Yeah. I'm pretty sure you can do that. But I think this doesn't work, cause you only have 2 items here, but then you can unpack like the sub items in. So I think that should work. So heap pop. So we want to heap. So we want to pop it. And now for the 4 directions. There's also one thing very, very important whenever we are dealing with whenever we are dealing with like traversing in a 2D grid, is we need a directions array to store the 4 directions. So because if we have this, what we can do down here, well, we can just loop through the directions, right? So for I guess we can do like dx dy in directions. So we have the new x and new y. That's going to be x plus dx, y plus dy. This is kind of bothering me, but I should really change it to x and y, because that's what I'm doing everywhere else except the function. So yeah, so that's how we get the new like position. Of course, we have to check if the position is valid or not. So is cell valid? Yeah. So then new x and new y. If it is not valid, we just want to continue. Otherwise, we actually do want to add that element into our heap. So we can do heap push, heap. So what do we want to put in there? We want to put the grid value. So something like this, and then we want the coordinate. So we can just do that. Yeah, we also have to check whether the element is seen as well. So so if yeah, I guess we can do it here. And nx ny in scene. So if we have seen it, we don't actually need that. So we can just do that. So like we can just continue and look at the next available thing. Yeah, so otherwise we can just do scene add, and then just want to do nx and ny. So we want to add that in. And that's also going to tell us the amount of elements that we have seen so far. So that would be like the size. So we can just do like length scene to get the size, right? So outside here, so this is either if the heap is empty. So let's say like we have seen everything already, or our top element is larger than what we want. So like that is when we will exit the loop. And also don't forget to increase the index here. Like we'll be looking at the next query. Right. So what we want is we want answer map. Yeah, which is this thing here. So we want the answer for our current query to be equal to the length of scene, which is the size of our connected component so far. And then we can just do that. And here we can just do a list comprehension, which basically maps the query into like using the answer map. So we can just do answer map query for queue in queries. Well, if I didn't mess it up, it should work. Oh, is there an infinite loop? That's kind of not what we want. Oh yeah, there's an infinite loop somewhere. Where are you? So it's definitely not here. And we are increasing index here, so that works. So it should be somewhere here then, right? So heap pop. Heap pop should actually, it does get rid of the element. So that should work. So for dx dy there. Right, I'm a tiny bit confused on where the error is. I guess we can just do some printing. So we want to print nx ny, so that's how you know we are adding that in. And also we want to check. I guess we don't have to check the size yet. Just do this first, so you know what element is actually getting added here. Yeah, I've no idea where the loop is. Again, it could be like really obvious to you guys, but yeah, where is it? Directions. That looks correct. And so we start with. Huh? Why do we have negative elements? Huh? How is that allowed? Did I mess up something up here? So nx my, so dx dy is that. Well, oh, it should be or. Oh, rookie mistake. Should be or here. I still get the wrong answer though. That's not quite what we want. Is it something to do with up here? Oh, of course. Wait, no, that's correct. So 0 gets us the mean heap's smallest element, and then this is going to give us the wait, what's that going to give us? That's going to give us the the value of the smallest thing, and for our sorted queries, so like this one, it will be like we'll start with 2, and we actually do want this to be strictly greater. Yeah, let's just print this out again. Yeah, it is getting 2 though, which is actually very strange. So so we look at wait, maybe this is not where you add this actually. Yeah. Oh, bruh. Yeah, it's like when you pop it, you want to add it here. Another really rookie mistake. Yeah, okay, now it works. So the reason you want to put it out here is so when you see a like when you go to a cell that works, you want to add that cell, not the neighbors, right? What I've done here is I've added the neighbors instead of the actual cell, so that's why the answer was so off. Surely it works. Time limit exceeded though. Let's see. So that's the grid. Just a lot of these things. Yeah, how can time limit exceed though? That's kind of weird. Yeah, this grid is so massive. Do we get the queries though? So we don't actually have that many queries, but this thing here is making it very slow. Wait, what are the bounds? Well, it's only 10 to the power of 5. It shouldn't time out at all. Like even if we are using a heap, is this the Python kind of issue? Because if it is, we have to write this in CPP. I don't know how else I'll optimize my code. Let's see actually. I think it's just slow. Like, is it because I'm printing some stuff? No, I don't think so. How else will we optimize the code here? Like we can so instead of using a set, I think we can initialize a scene list of list. Maybe that will be faster. I'm just thinking of different ways to optimize the code right now. So we have how many rows? We have row amount of rows, and then here we want false for something in column. So instead of doing scene add, I think this is where the overhead is. It's either this or the heap, but the heap we don't actually have a we don't actually have a choice for that because we do need the coordinate. Maybe instead of storing like another tuple, we can do that. That is also a way to optimize the code, and also that's a very small change as well. So we like that. And here, instead of doing scene, we can just do this. So scene xy is just going to equal to true, and then here we can just do scene xy. We just want to continue like we've seen it already, and of course here we can change this into one tuple, so hopefully to optimize it enough that it actually passes the case. Well, the user function here could also be an overhead, of course. Has no length. Oh, range. Okay, as you can see, I'm quite sick. I'm just hallucinating everywhere now. Yeah, of course. Instead of length of scene, we actually want to keep count. We can do like a component count up here. So every time we add an element into the, like every time we have seen an element, we want to add that. And then here we just want to set this to component count. If this times out, well, it is already a lot faster. That's for sure. But why is this not right though? What? It's all ones. Component count. Did I spell something wrong? Nope, didn't spell anything wrong. So we want to add one to this. Yeah, whenever I set this to true, I should have I should add one to this. Oh, am I hallucinating? Answer map, so sorted queries. Okay, where did I make a mistake? So or scene. So if it is not valid, or if it is seen, we want to do. We actually want the new coordinate. Is it gonna time out? If it times out, that means Well, either my algorithm is wrong, or Python is just too slow. So in that case, we do have to write it in C++, which is slightly not ideal because I haven't written in C++ for very long. Yeah, but I'm pretty sure that the actual code works. Wait, so actually in this case, it is just gonna add like each of the ones. It just goes through like row by row, right? I think. Yeah, I'm actually a bit concerned about the fact that it is timing out. But I'm pretty sure my actual code is correct. Let's look at the discussion. Recursive DFS will give you a TLE. Wait, but that shouldn't exist though. Wait, is that true? Let me print. Well, if their constraints are wrong, then it makes sense that it timed out. Cause I think if it is a million, and like because of how slow Python is, it would actually time out. Where's my standard out? Hello? What? I don't even get standard out now. Let's just see. Yeah, it shouldn't be the case. I'm writing this in C++. C++. Hopefully I remember how to write stuff in C++. So what we want is I think we can put it. Yeah, where do I put the global variables? I think I put it out here, right? Like in. I think. Surely. So we want int scene. Wait, actually, in C++, I can't just generate. I have to make a factor for it, like based on the size, like of the grid. So we want int row. So that's going to be equal to, I think, grid.size. I think that's how you get it. So int column is going to be grid0.size. What else do we need? Just go back here. So we want the number of queries. Number of queries. Yeah, we want the length of that as well. So number of queries is just going to be wait, what is it? It's just queries.size. So we also want the directions array, obviously. So we want directions. So int directions. But I think we can do this, right? If I'm not wrong. Bro, I actually don't remember any C++, which is a big problem. I think like we can do pair int. I think that's how you do it. And then we just do 1 0. That's how you initiate pairs. So I think this is how you do this. So we have the directions. We kind of inner functions in C++, and I'm quite lazy, so I'm just gonna like there's only one place where we actually have to check that. Oh, actually, I just want to try one thing. What if we don't call this function and we just like do it straight here? Is that gonna be fast enough? Let's see. I hope it is. And I'm not printing any stuff unnecessarily, right? I'll just mute that. Oh wait, actually, before we check, we can just return that, so you can see the actual size of that. Wait, invalid syntax. Oh, if not that, okay, yeah, we can write this first. So if not, so 0 should be smaller than, so nx should be in between, like from 0 to a number of rows, and the new y should be, well, it should be in between like 0 to the number of columns. So you can just do this. Yeah, we actually want to see this. That's kind of what we want to see. Yeah, what's the size? Huh? It's actually quite small. So I don't understand why it is timing out. Unless I'm just messing up some loops. So honestly, it could be my problem then. Yeah, it honestly could be my problem now. Now that that's on the surface. So answer map. Maybe the ending? Well, no, it's just gonna. Well, if the heap is empty, it's not actually gonna do anything, right? What about now? I've like optimized it a tiny bit here. Maybe I'm just like running into some loops that I'm not aware of. Well, answer map, that also shouldn't be too bad. Yeah, like even the number of queries aren't actually that big. Well, it is passing like the first two cases, I'm pretty sure. And well, this thing is also normal. Like it's not like very one-sided or something. Actually, let's look at this. So there are a lot of numbers here. And when we're so like we were starting on this corner. If we have 2 ones in queries, that's not gonna change too much, right? Cause like when we look at the next thing, but like the smallest element is still the same. Like if this is still the same, it would just not do anything there. It would go straight to here, and then we'll just go to the next thing. Yeah, what if we have like a whole bunch of wait, yeah, also we're guaranteed to only see each like each item like one time, right? Yeah, because of the scene thing here. Well, unless that's not true, then but it should be true. Wait, actually, could I be overpopulating the heap? Like if it is added in already, then we don't want to add it in twice, right? So maybe we do want the scene thing here. Yeah, let's think about it. I think that could be an issue as well. Like like if we have seen something and then like if we haven't seen something but we are like adding it in, so like let's say like we have seen like these two ones, it would add this one in, but then let's say we like in the heap it pops like this element first, then it will add this in again, which is going to cause a problem, right? Yeah, it would actually cause a problem. So we want to optimize that as well, I guess. So we have a component count. Yeah, I think we do this instead. So if we do this outside, so that's going to add the actual element in there. So scene, we do want to make scene 0 0 true. So like right now scene would be whether it has been added to the heap or not. Yeah, okay. That is actually the problem. Output. Yeah, I'm not printing any more extra stuff. Yeah, so the problem is like I'm only, whoa, that's insane. 98%. I never get that. I'm usually on the slow side. Yeah, but the issue was go to the drawing board actually. So let's say our current query is like 2. So naturally it will like go to the top left corner, and then it will add these two things in, right? Like because of the 4 directions. So that means this and that would be in the heap. So we have like 1 1 0 1, and then we'll have 1 1 0. And so we will look at 1 0 1 first, because like technically this is smaller. So it will go to here, and then it is going to add well, it's going to look at this because like all the other elements are seen already. So it's going to add well, like 1 1 1, and then like it will be done with, right? But then when we go to the next like element in our heap, it will actually add 1 1 1 again, because like in our code before, we only set something, like we only set scene to be true when we actually like see the element. And I think that's where the overhead comes in from. Yeah, so I guess I know why this is so hard, because like honestly, I still don't think this should be a hard, even though it took me, I don't know how long, like 30 minutes, 30 or 40 minutes to solve this. Yeah, yeah, it really should be an easy, oh, not an easy, it should be like a hard medium. But yeah, yeah, if you have any questions, make sure to comment below. I'll try to answer them. Also, if you want me to do like a specific question, also comment below as well. I'll try to do it when I get better. I'm quite sick right now. So yeah, thank you for watching, and I'll see you tomorrow. Bye.